Oh, hi.
Hello there.
We are in lecture number 8 on Moses stoichiometry.
Yep.
We're going to teach you how to convert molecular formulas into empirical formulas.
Yeah, which is really just reduce.
Reduce subscripts, reducing fractions to their lowest common factor.
Right. And if they won't reduce because there's a weird odd number in there like 3, then that is the empirical formula. So
Absolutely.
Don't get confused.
So here's the differences, right? Empirical formula for like hydrogen peroxide is the simplest form of the molecule's formula.
Right. HO.
It's not the real molecule. It's just been reduced for simple reasons.
Mm-hmm.
I mean,
and it can't get any more reduced. And that's when I'm, by definition, in the empirical formula.
Because subscripts can't be a half. They can't be a quarter. They have to be whole numbers. It's 1, 2, 3, 4.
You can't have a half atom. It doesn't make any sense. So you need at least a full atom. So now these real world molecules, the cool thing about them is they are some multiple of the empirical.
Right.
So these ones that we see, the H2O2, if I were to take that HO and multiply it by 3, I'd have
H3O3.
And I could make that real world molecule. And I could take that C2H5 and multiply it by 4, and I can get
C8H20.
Facts.
And it would be a real world molecule.
It would be a real world molecule.
The reason why this is in the content is because many years ago, we would actually have to be able to take an empirical formula, which you would find in the chemical lab. Like if you're asking the question, how the heck do you know that the chemical formula for water is H2O? Well, we figured it out using a technique that's no longer required to be taught. But what the artifact is converting between the molecular and the empirical formula back. We actually would use to find empirical formulas in the lab and have to do a little bit of math to figure out the molecular.
The weight is 180, and you'd find out that the empirical formula is 90.
Right.
So you'd need 2 of them. So you'd have to take that empirical formula, multiply it by 2, and then you got the real world.
So that's the reason why we have to teach this material. But we've actually simplified it down to as simple as it got to be.
Yeah, let's just figure out what the empirical formula is.
Yep. So simply reduce the subscripts that you're given by the greatest common factor. Fraction freak out. What? Factors? Oh my God.
No, watch. Look how easy.
It's not that bad. C6H12O6. I'm going to pick up the pen and think to myself.
Okay. What's the biggest number I can divide 6, 12, and 6 by? And that happens to be 6. So if I divide every number there by 6, I'm going to get C6 divided by 6 is 1.
C1. H2.
Oh, 1.
Is that what we get?
That's what we get.
So I got to write it? Oh, I thought this was a
I know you like to write.
H2.
Oh. And I don't need to write the 1. Remember?
Nope. Don't need to write the 1.
So there we go. That's that simple. Okay, next one. Here we go. C4H8. The biggest number I can divide these by is 2.
That's what I was going to say, but I don't think so.
Oh, what is it then?
I think it's actually 4.
Facts. 4. Well, I can do 4. So divide both by 4, I get 1, and I get 2. So it's just going to be CH2. Beauty-o.
There it is.
Good. Okay. I think there's one more. Ooh. 18. Oh, I see the 18. I want to divide by 9, but I can't divide 8 by 9.
No, I can't. I can divide it by 2, but that would leave me 4 and 9.
That's good. 9's a 9.
I was gonna try 4, but 4 doesn't go into 18.
And 8 doesn't go into 18.
And 8 doesn't go into 18.
2
the biggest number that goes into both of those is 2.
Yeah, they're even. So
2. So that would leave me with C4, H9.
And 9 and 4 don't reduce anymore, and we're done.
And you kind of also know that you can't reduce any further when your empirical formula has both even and odd numbers in it. Yeah. Let me write these ones in so that you can see.
Those are the odd numbers he's talking about.
Right. So there's 1 carbon, 2 hydrogen, 1 oxygen. None of those are divisible by anything other than 1. And if you divided them by 1, you would still get the same thing.
Right.
So it's as simple as it can get. That's what empirical means.
Now, the thing we did was, because we are really kind of keen on how to do it, we divided by the right number the first time. But if you were to take that first example and divide by 2, you'd see that C6H12O2 becomes C3, right? H.
Do you want to reverse and just do it again?
363, but I can reduce 363 farther. That's how you know you're not done.
Do you want to go back to that one and show that step?
We can if you want.
Let's do it. Yeah. So what Mr. Milks was saying,
If you pick 3 to divide by, because 3 will go into all those numbers, let's pick 3 and see
it's
what happens.
not the greatest common factor. It is a common factor.
Correct.
So we divide all these by 3 because you're like, well, I can't think of anything else. Let me just try 3. You would get C2H4O2. And then you would see, I'm done.
3, 6, 3, but you're right. So it's 2, 4, 2.
You would see that, I'm done. Well, you're not, because you're not in the simplest form.
Right.
All of those numbers, 2, 4, and 2, are divisible by
2.
2. So you could actually just do it another step. You could do it again.
Facts. As a matter of fact, what we're recommending you do is if you pick a number as a factor and you come up with something that can go farther, you must continue to go farther until you can no longer go farther.
Mm-hmm.
Does that make sense?
Absolutely. That's how you get to the lowest common ratio, the simplest ratio of subscripts, which is what empirical formula
Really is all it is.
Do we have anything else to say about this stuff?
It was really simple.
It was really
But you
simple.
do some practice. And
Absolutely. We're just making
gotta
sure.
go through it.
That's it. That's all there is to it, folks.
fast video, love it.
Don't let it being so simple mean that you forget it so quickly, too.
Ooh, yeah. Because you know you're going to have to do it on the dust.
Click the button and turn off the video.